This is possibly the easiest or one of the easiest sections in this chapter. It's called the enthalpy formation, and it's symbolized by a delta H with a subscript F and a superscript 0. So what it represents is the enthalpy for formation of substances from their standard states. We'll talk about ammonia and we'll talk about sodium chloride, but let's first digest what is delta HF0. F stands for formation. Nice that they let us know. The superscript 0, it means a standard state. And what is a standard state? It refers to an element in the physical form that's stable at 1 atmosphere. So by definition, an element in its standard state is 0. We know oxygen is the element, but in its standard state, it is a diatomic molecule. You've had to memorize that so far, but we'll be showing with Lewis structures why that really takes place. It all adds up as we look at everything. So the question is, what is the enthalpy of formation for NH3 and NaCl? This is how easy it is. There is a nitrogen and there is a hydrogen in NH3. And 1 has to be the coefficient for whatever material we put as a product. What is nitrogen in the standard state? It is N2 as a gas. What is hydrogen in the standard state? It is H2 as a gas. So we need to write a balanced equation. That means we will have to say 1/2 N2 as a gas, and we will have to say 3/2 H2 as a gas are going to give us the 1 ammonia. I honestly can't think of anything easier. Very, very, very simple. Run through some. So what if we have something like sodium chloride? It has sodium, it has chloride, and it's going to make 1 sodium chloride. What is sodium in its standard state? It is a solid. What is chlorine in its standard state? It is the diatomic gaseous molecule Cl2. What do I need to do to write my equation? Well, I only have 1 sodium and I only have 1 chlorine. So if I were to write the enthalpy of formation equation, it would look like this. Again, I just can't think of anything easier in this entire section. So what else is there? Well, you can find the values for the Enthalpies formations in Appendix C, but you can also find them in the table 5.3. We'll be using them as we do a little bit more sophisticated work, but for now, that's all you need to know. If I look at an equation and they say, using the enthalpies of formation, write the delta H of reaction. So we're looking for the delta H0 of reaction, and we're saying use delta H0 formation. So there's my given equation: hydrogen sulfide, oxygen, water, and sulfur dioxide. I look at hydrogen sulfide, I write a delta H0 formation equation. I look at water, I write a delta H0 formation equation. I look at sulfur dioxide, I write an equation for sulfur dioxide. I look in a table in order to find the values. Why didn't I do oxygen? Well, oxygen is in a standard state and it has a value of 0. So it doesn't even occur as we write these enthalpies of formation. Once we've written them, we do just what we did in Hess's law. What am I going to do? I'm going to say how you do it. If I look at H2S, I've got to find it. I see that it is sitting right here, but I see there's only 1 of them. So what I need to do is I need to reverse that first equation and multiply it by 2. I love to write things down, but I realize it would be very, very hard to squeeze this into a video. So take some time, look at equation 1, notice how we've reversed it and we've multiplied by 2, and notice that in the reverse, the negative became a positive, and we also had to do the same thing to the delta H0 formation. Now you do this with each and every one. When I look at the next material, water, I see there are 2 of them. There is only 1 water as given. So what I'm going to have to do is multiply that second equation. I don't have to reverse it because water is a product. I just leave it by itself. So this value has come about by multiplying by 2. And there we have it right there. As for our third equation, well, I'm looking at it and saying, what? Well, I see too many elements. But what my eye goes to after I practice these a lot is it goes to the SO2. And I see that there are 2 SO2s present. So I will have to multiply the third equation by 2, and I will have to multiply correspondingly the delta H0 formation. Then I'm going to step back. I'm going to say, okay, what cancels out? And again, trial and error. Goodbye to the hydrogens, goodbye to the sulfurs. Oh, we don't say goodbye to the oxygens. We add them together and they stick around. The H2S is just fine as it stands. And as I look, there is my waters, there is my SO2. So I've got everything added up in terms of the equation. What I need to do simply is mathematically combine the heats of formation. It is laborious, but to me, there's facts, there's a method, there's a problem to be solved, and it gives you insight. It tells you when you have hydrogen sulfide and oxygen, if it combusts, it will make H2O and sulfur dioxide, and it is a very exothermic process. Okay, so that's kind of the take-home message from the facts we've learned in this chapter. What's on the last page? Well, I know this is heats of formation, but you can also find the answer with Hess's law. If you have numbers in the table, so that's where all these numbers came from. I looked them up. It could be in the appendix or in the table. Hess's law says take the sum of all the heats of formation of the products, subtract from it all the heats of formation of the reactants, and take into account the stoichiometric coefficients. So that thing you learned all the way back in chapter 3, we're using it now in chapter 5. And I like to say that because Khan Academy, Sal Khan says, you know, you can have Swiss cheese learning. If you're missing something in the beginning, it's going to multiply itself as you go on. So I hope you've been putting in the time to grasp the things from the beginning. So now when we're teaching you new things, they're starting to flow. So since there is a 2 by the H2S, I will have a 2. That's one of my reactants. My oxygen, of course, it is a 0 because it's the element in the standard state. I see a 0 in the table if I were to look. And then I have 2 waters. There's a 2 there. And I have 2 SO2s. There's a 2 there. Now, I'm a practicing scientist. And like you're a college student, you may say, take shortcuts. If you're working in the real world, in the business world, you have to be accountable for what you're doing. So what I've done here is I've put down all the numbers, and that's just how life goes. When I add everything together, I come up with a negative 1125, and either way, whether you use heats of formation or Hess's law, you should get close to the same answer. I hate to say that's all that's in this section, but that's all that's in this section. Please practice by either Alex or your end of chapter homework so you're prepared for the exam. And as usual, I sound like a broken record. Please, please, please ask questions.